Hello, this is your teacher bot. All systems are functioning normally. Now what I'd like to do in this video is talk about 249 data structures, the second lab, and the second homework. So M2 Lab 2 and M2 HW1. So the first homework in this module, but the second homework overall. First of all, please notice that if you want to use a particular language, this is a good 50-page guide that you can use to look things over. I recommend you take a look at this book, which is free, and it'll give you some notes about complexity of algorithms and analysis of algorithms, the things we're getting into as we move forward into Module 3, which will be dealing with sorting. All right. You may also find these two useful. This is for next module, so I'll move that. Talking about complexity and some of the things that the Zybooks gets into. All right, so we've covered the tutorials already. We covered the first lab. Let's look at linear search. Now, we're going to be looking at linear search and then binary search. With linear search, you have to realize that you're going to look at each item in the list. If I have here this collection, well, I've got to check each item to see if it's available. Now, there is a trick where if the items are sorted, let's say I'm looking for the number 12. Once I get here, I know there's no 12, so there's no reason to keep going. In this implementation, you may or may not want to do what's called an early return. But whether you check all of them or about half of them, it's still big O linear, as you'll see in the reading. So this is the algorithm, the pseudocode that they want you to implement. You can see this is kind of like a mix of Python and C++. Please note, however, that depending on your book, you can just go into figure 231 for either Python or C++. And this is the implementation, which is very similar to what's given in the pseudocode. So essentially, you could start with just typing this in, and if it works, then you're set. Okay? So we're keeping this lab fairly simple to see that you can implement pseudocode. Now, the interesting part here, in my opinion, is dealing with binary search. Okay, and I want to give you a little bit of background about how the gold, silver, bronze tiers work. I recommend you start with bronze, and then if that works, go to silver, and if that works, go to gold. So let's say if you during this weekend through the 5th, if you can get bronze done, then you've got a week to work on silver and gold. And the idea here is you should not go straight to gold because this is actually 2 programs you're building. So first of all, you're going to take the code in the next section. So you want to compare and contrast the linear search algorithm with the binary search algorithm and see how this looks. Okay, and read that over and understand why it works the way it is. They have you do some questions here to kind of see what's going on. So let me kind of give you an example here. I'm going to run this code and I'll show you what's going on here. So I've actually added a few items to make it a little more interesting. So we've got 16 different numbers here. And I've added a few debug statements to kind of show what's going on. So I'm going to search for the number 16. And as you can see, it's looking between 0 and 15, so the entire list. And it checks the middle of that, which is 15. Well, 16 is greater than 15, so you can eliminate everything 15 to the left. This now means 8 through 15 are your new high and low. So every time you check one value, you're eliminating half the list. And the reason you can do that is because, again, they're in order. So if the number is greater than 15, then nothing on this half of the list is useful. So each time you pass through, you're cutting this list in half. So next time I go from 15 to 8, and I go to the middle of that, which is 45. And then now I'm searching between 8 and 10, and it's got to be one of these. Sorry, 8, 9, 10. There we go. I was off by 1. And you could find that it checks 32, and then it looks at this one. Let me give you another example of a number that's not found. So what if I put 17? Again, here, you can see, well, it's 15 is too low, so now I'll check this half of the list, and then I check that half of the list, and I go to the middle. So 45 is too high. I go to the middle again of the half because I'm cutting it in half each time. And then 32. And then finally, well, if 16 and 32 are two adjacent values, then 17 is not found in the list. So instead of checking all 16 values or even checking 8 of them, I make 1, 2, 3, 4 comparisons, which is pretty good, pretty efficient. Okay, that's bronze. So bronze is just making this code work. And again, you can use either the C++ version or the Python version. And you'll want to play with this code to make sure you understand how it works. So now how to finish the project. Well, for silver, I want you to take the idea of binary search, but you don't use a vector or you don't use an array or a list. You're just using a series of numbers. So what would that look like? Right? So if I just think about here, I'm just going to type some values in. It's not going to work. I'll show you what I mean, right? So guess a number from 0 to 299, and then start at 50. Right? It's okay. This is going to be really stupid. I'm not going to do that. Let me instead just use a regular notepad here. Okay. I'm going to pull up a plain old file new. Okay. So what's the algorithm here? So I'd say ask the user to guess a number. Let's say from 0 to 99. It could be 0 to 10, however. First guess is 50. User types less than, equal, or greater than. If equal, we're done. You guessed it. Remember, the computer is guessing it. If less, now look between 0 and 49. If greater than, now look between 51 and 99. So just like in binary search, a binary guess is just picking a number. Whereas in the binary search code, you looked a number up and then said, okay, I want to look up the value at that index. So index 7 has 15, index 11 has 45. Well, we don't do that step with just guessing a number. With guessing a number, all you do is it 50? High, low, equal. Okay, is it 25? High, low, equal. Is it 12? High, low, equal. So you're implementing something similar to binary search, but you're not using an array. So it should be simpler for you. Now finally, what I want you to do for gold is just assemble these two programs together into one program. So what that means is you need to create a menu. So your main would print a menu out and you offer them these three choices. And then you loop and you have an if statement to check to make sure that they selected one of the good values. So you might say press 1 for binary search demo, press 2 for guess the number game, press 3 for quit. Now, of course, you've got to handle the case of what if they type in 0 or 4? You've got to loop the menu. So 80 points for implementing the existing code, 10 more points for turning it into this version, which is similar, and 10 more points for assembling it all together. So as you can see, if you press for time, just do bronze and turn it in. I would encourage you to aim for silver and then gold, but it's not required. One last point for the homework. Make sure you actually say what you aim for. Because if you don't say what you aim for, you're going to get graded for bronze. Okay, that's a fairly short video. Hopefully that's helpful, and I'll talk to you later.